Hello friends, welcome back to the PythonShow after 2 months break, right? Well, let's be fair, it was summer and I thought, yeah, all of you had perhaps better things to do, me including, but now we're back and hopefully not because of Corona, hopefully we are back, let's say, from the summer holidays and there is no second lockdown. Let's start with a general overview of what has happened or what is going to happen in the nearest future. So I'm more of a future-oriented guy, so I want to pitch some conferences for you. I don't have any personal connection there, but that's Python conferences. They're always good, so I can by default recommend you every PyCon, including this. So one, it's DjangoCon Europe. This happens, I think, tomorrow. They had free tickets. I think they're all gone now. However, even the regular tickets are something like 30 euro, so it's a fair price, I think. And it's recommended. I've been there 5 years ago. I think they should get even better now, and it's Django, so they should know how it works online. Then there is PyCon APAC. It's the Asian PyCon. It's also interesting because I wanted to go there for quite some time. I mean, for real, to fly there. It's just so far, it never worked for me. So now there is a chance to actually do it online, but still. So also recommended. And there is PyCon Turkey. This all in September, so you can just Google it to find the exact date. I know for sure that PyCon Turkey is, I think it's for free. So there is no excuse. And it's their first conference, first ever PyCon Turkey, as far as I remember. I hope I'm not wrong, because 2 years ago at PyCon Slovakia, and we have quite a strong connection to PyCon Slovakia today. So on PyCon Slovakia 2 years ago, there was an organizer of PyCon Turkey telling that he plans to do this conference. So he asked for some tips and all of the organizers gladly shared them. And now they're doing it, so it's really cool. I will certainly join to check it out. I didn't submit any talk, too late, but I recommend you checking that out anyway. I'm sure they have a great lineup and quite some fresh views on this. All right, so I don't want to take more of your time because we have such cool speakers today, and let's start with the first one. The first speaker today is Isabella. Isabella, welcome.
Hello everyone, I am Isabella, and I'm here to give you a nice talk about bioinformatics.
Great, cool. Isabella, so before we jump to your talk, let's have a bit of introduction. So I think we met on the meetup, and I think it was an online meetup some time ago, right?
Yes, from PyLadies.
Yes, perhaps. Right. So Isabella,
it's a long time ago.
Yeah, but already that time, now everybody has fancy webcams, fancy mic and everything. When the lockdown just started, nobody had it, me including. But you did.
Yeah.
So you're a streamer, right?
No, but I did this camera I bought not so long ago because I use it to stream some even years ago, but then life happened. I wanted to, do my master's and have good grades, and I kind of stopped with this gaming life for a bit. And now I'm back into it a bit, not so much. I don't have so much time. But then yet now I got a new camera, a new set of microphone, and yeah, I'm just getting back to it.
Cool. Well, it looks really good. It sounds also very good. I'm super happy when I have such an easy preparation with the speakers. But give us a bit of a context. So you are a gamer, a streamer, biologist, and software developer. Is that the right mixture?
Yeah, that's true. I studied biology and I did my master's in neurobiology, molecular cell biology, but I didn't enjoy to work in the lab too much. So I did like a small practicum in the department of bioinformatics, and I just fell in love with it. I always learned programming by myself. So yeah, it just felt so good for me that I wanted to stay in this field. So afterwards, I started working a bit with bioinformatics with Python. I did my master thesis using Python for data analysis. And now I am only with software development, but it's something that maybe in the future it can change. I'm not sure. I
All
still love
right.
science anyway.
It's
Yeah.
in your heart.
Yes.
Okay. Good. Then let's start with your talk first, and then we have Q&A, and we can also discuss more of your streaming second life maybe after. But first, we are excited to hear about the DNA and exploring our genome with Python. So can you please start the screen sharing, and can Mr. Boris please give us some support on this?
So I'm going to talk a little bit about how we can explore the DNA with Python. I hope you guys can cope a little bit with me. I need to give you some basic introduction into biology so you can understand the problem and what we can explore using Python. So first of everything, what is the DNA? So the DNA is our hereditary material. So it comes from our family, from our parents to us, and brings all our genetic information of how we look like and everything. In human cells, it's mostly located in the nucleus, but there are also some small amount in the mitochondria. I hope there's not so many people there that also did biology. It's really just so basic. It's kind of almost not so true. But yeah, it's really just superficial enough to understand what's going on. So we have the DNA in the nucleus, and its structure is in double helix strands. It's 2 strands, and they are organized and compact together into the chromosomes that are inside the cell. Fun fact, all our DNA from our mitochondria are actually from our mother, not from our father, from all of our cells. Our mitochondria has the DNA that came from our mother. My cat is annoying me. Oh my God. Stop, cat. Okay, so the information inside the DNA is stored based using 4 bases: adenine, guanine, cytosine, and thymine. We are going to talk about them and from now on only by the first letter, T, C, A, and G. And according to the sequence of these letters, some protein can be codified and produced by the cell. These bases also, they always get together. Adenine would always bind to thymine, guanine will always bind to cytosine. So why is important to duplicate the DNA? The most important step is the replication of the DNA, because it has to be replicated in order for the cell to divide and have copies, perfect copies of the DNA in both cells. So how this process happens? The double helix, it splits apart. We have the 2 strings here. They split apart, and each one of those strings act as templates. And then new bases are bind to this template, and then we have 2 copies. And then each copy goes to one cell. And always adenine with thymine, guanine with cytosine, and so on. Now, one important question for biology, for agriculture, for science in general, for medicine is where this replication starts. Why? Because it's important, for instance, for gene therapy. If you want to insert a gene that the person has that it's not working, and you just want to put this gene back there to make it work to produce some protein, you have to know where the replication of the cell of the DNA starts so that you don't disrupt this process. Or even more simple example, like when you need to insert a gene that produces insulin in the bacteria, you also need to know how the bacteria reproduces itself so you don't disrupt this normal process. So otherwise, you're going to kill it. So this replication is done by a protein called polymerase. The strands, they unwind, they separate from each other, and then the polymerase binds to one of the strings and then associate new bases and just expands the new DNA, and then at some point it just pops out. So if this process is so important, how can we find this origin? So there you go. Biologists would go to the lab, would just break the DNA in 1,000 pieces and then put it together again. And according to what piece is missing, they would say, that's the one. But you have to do that so many times. You have to duplicate it so many times that then the computational biologist said, hey, we have a computer. We can use computers to do that. We don't have to be the machines if we have machines. So we are going to see how we can find this origin that can also be called ORI. We are going to use bacteria DNA right now because it's very simple. It's easy to understand. And in this case, we are going to use cholera bacteria DNA to understand. And it's known that in bacteria, there's a specific protein, the DNA protein, that binds to specific regions in the replication origin region that signals, hey, you have to start here, polymerase, bind here. And this place, this little region where this protein, the signaling protein, binds, is called a DNA box. These regions, these boxes, appear a lot of times in a short period, in a short region, because it's very important. These pieces are needed so that the protein knows here's where I should start to replicate the DNA. And when you have more of the sequence, then it's easier. It just happens more fast. And for another reason, because it also protects the cell. So if some mutation, for instance, happens, there is a lower chance that this mutation is going to disrupt exactly that very important region where everything happens. So this is one tip. We need to find a region where some sequence happens a lot. That's already a flag. So in this example, we are going to see the cholera. As I mentioned, the bacteria DNA is just circular, so it's very easy. And here there's also an example of a DNA that was inserted into the DNA of the bacteria. So to do this, you need to know how not to break everything. Here is an example, and it's a true example. This is a little piece of the DNA of the cholera. And you can see that there are like 5 letters, one after the other, that repeats each other. These patterns repeat each other, appears 3 times. Again, AC is just like the bases from the beginning: adenine, cytosine, thymine, and guanine. So we see that they appear 3 times, and it can be something interesting. So if we start thinking about a more functional, more computational way, we could just write like a function that counts this pattern, how many times it appears in a certain string. So to say, look for substrings in the string. We are going to call this substrings, these little patterns of Kmers, and K will be the size. So if it's 5 letters, it will be 5 mer. So I actually have even the whole genome here just to show you how it looks like. This is 1 megabyte of cholera DNA, and it's for real. Anyone can use it to explore and to find out what it codes, if it codes for a specific protein or something. It's there in the internet. So this is very nice because it's a basic protein and we know a lot about it. And this is actually the origin of replication of this bacteria. And if we use that function to calculate how many times different sizes Kmers appears, we can see if we find something interesting. For instance, a 3-mer TGA, I also made it bold here, appears 25 times around this whole origin. However, it's a very small Kmer. It's only 3 letters, right? It's very easy to get this kind of results. And furthermore, we know because of research, we know that the DNA box in bacteria always have 9 mers. So the size should be 9. And here we found 3 9 mers that repeat itself at least 3 times. I prepared, oh no, that's I prepared for you guys some coding. Yeah, so here I have exactly the same sequence, so I can show a little bit more practical approach instead of just text. And I also did here a little function that extracts for me all the Kmers that I can find in the sequence. So for instance, if we want to get all the Kmers in the sequence of size 9, what I did here is just a naive loop. I just get 9 letters plus 1 index 9 letters plus 1 index 9 letters, and so on and so forth. So I'm going to try to run this, and here we have then the list of all of 9 Kmers. If we want 3, we could also just change for 3, and we could have different sizes Kmer to study. Good. So another thing we can do is take this Kmers and count how many times they appear in the most common one, which one appears the most, so you can see if they are significant at all. So in this function, what I did was I'm just calling the same function that created these Kmers, using the sequence and the size of interest that as an input in the function. I create a dictionary. Then I initialize my dictionary with a count of 0 for each Kmer that we got from this list. And then all I do is also loop. I compare, I get the first Kmer and I compare to all other Kmers in the string with the same size. And then we get the max. And of course, if it matches, we add 1. And then we try to find out which value is the maximum, which Kmer appears the maximum of times. If every Kmer appears only once, we are going to have a count of 0 still, and we just return a string. And if there is something that is different from 0, then we check, we get this result and put it into a return list here. So I have to actually first, I have to do this. Sorry. Let's put 9 so we can reproduce the same from before. So here we go. Then we have these 4 results. These are the Kmers of size 9 that repeats itself the most, and you can see that it matches here in this little table. Just a second. Yeah. So I mentioned before that the strands, they bind to each other. And these bases, they get together, adenine with thymine and cytosine with guanine. And actually, they complement each other, and the sequence means the same for the protein. So the DNA is actually read from this side to this side, 5 to 3. And the other strand is only in the other direction, and it's also read from 5 to 3. So actually, these two results are complementary of each other. Not because of from below, you have to get the complement, like he would be T, he would be A, and then you have to invert it because it's read from the other side. So that's why this is complementary from each other. This first one, for instance, appears 17 times in the whole genome, not only in that small origin, but in the whole genome. And if you check for the index where these Kmers appear, there are some indexes that are very close to each other. We call these clumps, and that's also a flag because, as I mentioned, these boxes, Kmers, they are just the DNA boxes where the protein binds, right? So these boxes, they have to be together, close together, and appearing in multiple times, so it increases the chance of replication. So this is a flag that this could be the origin. And if you check the complementary string, it also appears exactly 3 times in the same region. So it's a big flag that it might be where the replication starts in this genome. So there are some other factors we have to take into account. For instance, the Hamming distance. I didn't know that, but I found out that it's also used in technology to analyze if there's any loss of data in transfer, for instance. So you can calculate the difference between the number of bytes using Hamming distance, so you can see if there was a package loss or something. And the same is valid for our Kmers. Why? Because mutations are really common. So if you want to give a little bit of freedom to your DNA, especially in human DNA, where we are all the time replicating and these kind of small errors are common, you have to give a certain freedom to your algorithm to find these Kmers, even if 1 or 2 bases are different. It won't be so important. So in this function that I did here, it's also very basic. I just start with counting of 0. I input 2 patterns, and I check index 0 of each one of them. And if it's the same, I don't do anything. If they are different, I sum 1. And in the end of all the indexes of these patterns, we return the counting. We also can create the complementary strings directly in our code. As I mentioned here, you can see that the string is actually just in the opposite direction. I create here a dictionary for each one of the bases and what is associated to it. And then, we just create an empty string. We get the match according to the dictionary. And then we add to our empty string and revert it. I created here a dictionary as well, just for the sake of sanity. So I keep the original Kmer and the complementary one. So in my code here, I commented out some stuff. I have to fix this. We are going to insert the difference for now, the Hamming distance. And we also need this, and we need this. Okay, here too. So we can see just the code running. I got both versions here for us. So not so much to change. So let's say that we want to know the most common 5 Kmers in the sequence, but we allow the difference of 2 bases among them. Let's see if I didn't forget anything. I'm going to use the list here. Okay, let's give it a go. If I forgot something, I find out because I was seeing an error. Yeah, true. I have my functions here and I didn't submit it to the environment. I'm sorry. So it didn't find the function. And I also didn't use this. That's the dictionary with the complements. Let's try again. Okay. So we have only these two that are five of length, now 5 Kmers that actually appear multiple times, and they differ itself from others from only by 2 bases. If you want 0, I don't even know what happens. Yeah, you see it's different ones because it's more restrict. Only if the selves appear more than once, they are going to be there. Yeah, it's too much. Yeah, well, doesn't matter. That's how we look for it. So this is the basics to look for the origin. And then the question is, how do we find then these clumps of Kmers, these multiple Kmers, so that we know that repeat themselves, so we know that that's the origin. The genome is huge, but in the bacteria, we know that the origin, normally the size is of 500 bases, so you can just pick this window and then you slide it and you check the Kmers there. If there are some special Kmer, big Kmer repeating itself, it might be a flag. If not, you just keep sliding this window. Yeah. And another thing that can help, for instance, the perfect E. coli, we know everything about it. It's, I think, the most studied organism in research in the history of science. Another thing that we can use is the quantity of guanines and cytosines because of mutations. During replication, the quantity of guanine is very high when the polymerase is moving from the origin to the terminal. And the other way around when it's going from the terminal to the origin. So we can use that to our benefit. If we just make like a graphic of the quantity of guanine and cytosine, we can find out where exactly these points could be. This is just too perfect. It doesn't look like that for humans, for instance. But then we would know that where we have the less concentration of guanine, here starts to increase again. Here it's decreasing. So when you see this big change, that's where that's where it is. In a perfect world in the vacuum and everything. And that's it. I wanted also to talk about probability and statistic that we can use, but I think it would be a bit too much. I brought also here a piece of code that we can use to calculate to make this Q. So for instance, it would be what we could get from the code to make the graphic. In the end, all we need is the lowest point, the minimum. And then we get the index of the minimum point, 502. And in matter of fact, it's this one. It's minus 15, right in the end for this sequence that we have here, right? For this sequence. Yeah, that's it. And then we can just make a graphic of it. And it helps also to identify where the origin might be. Maybe another time, in the next time, I can also show how in more complicated genomes, like in the humans, you actually have just to roll dices and just go for a random number to find these places. And it's much more worthwhile than any of this very restrictive and brute force algorithm. But for today, I think would be already too much. Yeah, that's it. Thank you, everyone, for watching. I hope I wasn't too difficult with my biology explanation. And if anyone has any questions, I am open to answer them. I
Bravo,
leave
bravo,
there my contacts
bravo!
as well.
Great talk, Isabella. Yeah, Isabella, it was, let's say, not easy to stay, connected.
Yeah.
This thing is advanced, in my opinion.
Yeah, it's a data analysis. It's data science, actually.
Yeah, it's data science plus biology.
Yeah.
So I'm wondering, like, when you did your master thesis about the similar topic, right? I'm wondering if all of the professors listening to you could actually understand all of it. Because if you're a professor in biology, you not necessarily understand development and another way around, and to understand both as good as to qualify for professor. I don't know how smart one has to be.
Yeah, I did my master thesis actually in the Department of Biological Systems in my university. So everyone was just working with bioinformatics there, and I definitely needed their help for it, so they could understand. But I did it in a company, and I just had to kind of link together both university and the company, the informations regarding the data, to explain the data to my professors was kind of a big challenge. Yeah, because when you produce the data in the lab, you know what you're doing. But yeah, and everything had to be secret. I couldn't talk to everyone about it, only with my professor. So
Crazy.
yeah, it was not so easy.
All right, if we have questions, please post them in the comments. Now I see one question from Anna, and it is, does it really not matter at all where a sequence starts?
Yeah, exactly. It's really important to know where it starts, so you don't disrupt when you're manipulating it. For instance, you want to adapt a plant to survive a certain weather environment condition, and you want to put there a gene that codifies a protein that is going to help the plant with it. You need to know where the replication of that cell starts so you don't break it. Because if you put the gene inside anywhere, you might disrupt something very important, and the cell won't be able to reproduce, won't be able to duplicate anymore, and it's going to die. So it's completely opposite of what you want. Or gene therapy, if it's a person, you need to know where the replication of the human being starts so you don't touch it. And it's actually not just one origin, right? It's many origins in the humans. Our polymerase, they bind all over our DNA, and they duplicate it simultaneously all the time. We have 3 billion bases, and they are all the time right now in me and you. They are already multiplying and replicating your DNA. So if you change one of those starting points, you can already damage the cell and the person. So
Now
yeah,
it's scary. Bella,
yeah,
what have you done?
it's scary.
They are multiplying everywhere.
Yeah, they are.
What if the sequence goes wrong? Okay.
Yeah.
I have a question also.
Yeah.
I'm coming more from a developer side. So I know that in biology, Python is maybe even like a dominating language for research, because first of all, the data analysis tools, but also the libraries that they have to connect to different data sources. So how about this field, the topic you talked about? Can we say that if you are researching the DNA, then you do it with Python? Or are there any more focused tools in the scientific community?
Yeah, actually, all these algorithms that I have written myself by hand, there are softwares that can do that anyway. Most of them are very expensive because these algorithms are really complex and they involve. They're not so complex, but they take too long. So depending of the computer you have to analyze 1 megabyte of DNA, it's going. I swear to you, when I did this first time, I had to wait 2 hours for my computer to do the analysis for me. It was the first time I was writing the code. So there are some softwares out there that does it and they have been improved. There are teams working on it all the time. And I think they must be very good as well. I also use it R, however, the programming language R to do some statistics analysis. But for biology, there are still a lot of libraries for biology in Python that helps a lot. It's really useful and it's worthy.
Cool.
Definitely.
Cool. Thank you. We got more questions. How big is a human DNA in a Python array? It's a good one.
Oh, gigabytes.
Oh shit.
If that one that I showed was like from Cholera, and it has 1 megabyte, and it's so small. It's ridiculously small. Humans, we have 3 billion bases. So imagine you can try out and tell me how much weights how big it is a notepad file with 3 billion letters. You can just type one letter A. Just put 3 billion A's in one text file, save it, and tell me how much it is. Then yeah, you can see the file itself. But it's not always like that. The file, you can see different files that are easier to be read by the computer, to be compiled by the computer. You can also find in some web pages. Also, everything's for free. This kind of stuff is for free. Who has interest can download to do science at home. Actually.
Okay, that's nice. I'm sure nobody can start it so easy without a proper background, but it's cool that it's so accessible. Okay, yeah, we got some hints of how big the array could be. Yeah, it looks big. Let's just say that. There was another question from our same viewer asking about scaling of the Python code. If you need to scale it, and how do you scale it?
When I have to scale, like, what do you mean?
Well, I don't know. I guess if we have such big files, if you need more, I don't know. It sounds like the very big data. So how do you, if just one DNA array takes gigabytes, did you ever encounter performance issues, and how do you deal with that?
Yeah, exactly. That's one of the big issues in computational biology because there are not so many alternatives out there. In the end, the DNA is just a big string, and you have to go through it to find information. And that involves a lot of loops and looping through strings and multiple times because normally you have to compare, right, to different patterns in a big string. And then you can slide this window, of course, to kind of limit how long do you want to look for similar patterns, but it's still a very very complex thing regarding the compiling time.
I can imagine.
There's no way to run around it. You need a good computer and just wait one day for the results. Unfortunately, I had to leave the computer in the company running and go home, sleep, go back, and then you see it, the results.
Got it. Okay. Does the university provide something for research? Access to
The
data
computer.
center?
It wasn't the university, it was the company. They gave me a nice computer, external hard drive that was a little bit stronger. They use it to use for machine learning, and yeah, it was only for that, so it was pretty good. Pretty good. I think, of course, it was already 2-3 years ago. So I think my computer now is even better.
Good. Okay, let's jump. We have more performance comments, but we will jump to next question. You said you changed to bioinformatics topics for a master thesis. Was it complicated to get into that field coming from the biology master?
Yeah, I always learned programming by myself. I always liked it, so I already had some notions of Python. I already could do front end at the time, and I just like it. I don't know, it's so hard to say because I love learning it that it wasn't so hard for me.
Cool.
Of course, I think the hardest stuff was like the basics of computer science, like the logics behind the coding and the functions. Or I don't know, sometimes people, I would see some, like in interviews, people would ask something about binary trees. And so like really the basic, but I didn't need it that much at the time. And of course, once I got the logic behind one programming language like Python, I noticed that actually you can learn any programming language so fast once you understand what's going on. And it was just that kick, I needed to understand that logic, and then that's it. It was done.
Cool. Okay, that's great. Let's have one final question. I'm not sure. It looks more like a comment. We have some similar already. So yeah, if you only have 4 letters, does it make sense to use strings? Yeah, I mean, from me personally, in the science, the optimization is usually not the #1 priority. I don't know what Bella says about it, but I saw a lot of the scientific code and talked with them. Like, yeah, you can always push for performance. So the question is if that's really the goal. Bella, what do you say about this?
I mean, what would be a good alternative? Because in the end of the day, it is a text. It is it's just it's like our language, but it's a language made of 4 letters. What I have seen already is some bioinformaticians. They created DNAs containing 6 letters to store data, not programming biology data, but data. Like they store books of Shakespeare, the U.S. National hymn and everything. They put it in there because that's really reliable. It lasts forever and it's really small. So you can keep just a little bit tiny of DNA that contains gigabytes of information. And yeah, and nowadays that we produce so many data, this would be an alternative for storing information. Store information in the DNA.
Cool. Thank you very much. I think that we can close this part now. I just say that people loved it. I see good comments. I see people asking also for the code. So if you drop a link to GitHub or whatever, we'll publish it here.
I can put it in my GitHub.
Cool. Yes, and before we go further with today's program, one last thing. So about your second life, the streaming life, tell us, what do you play? You stream all of it? Where do you stream it? I mean, let's do some promotion. Let's paste the link to your channel. Why not? We'll need some relaxing after a hard day of work. What do you play?
Yeah, my channel, I started the channel like 6-7 years ago. I started streaming Dota 2 and Counter-Strike. Then life happened. I stopped for a while. Now I stream some single players, Call of Duty. I'm trying to get back to it. And I also do live programming sessions every Saturday. I do 1 or 2 hours, and I code live, and then people including, I saw that one of the people watching and commenting is one guy that came to my channel in Twitch.
Nice.
T-Rex is there. T-Rex,
cool.
Yeah.
All right.
He is one of the guys interested in the live sessions. And I have also a poll in the channel. You can vote for a topic that you want to be seen in the next session.
Nice.
And then I code and we make the program together. So yeah.
That's cool. And you stream on Twitch, right?
Twitch, yeah.
Good.
BR of Brazil, BR Belinha.
Okay, I'll just post the link in the description of the video so everybody has it. But remember, if you follow Bella on Twitter, she posts links somewhere, sometimes over there. I saw it. And Bella's Twitter is already in the description, so it's easy to find her. The programming session is that Python?
I am organizing a Python one, but mostly it's front end for now. It's JavaScript and HTML, CSS.
Full stack, biology included. That's nice. Cool. Okay, then let's say a big thank you to Isabella for delivering such an advanced talk in understandable way. Thank you very much.
Yeah,
a big applause from me, from the audience, from everybody. If Isabella stays around, you can chat with her after the show as well, when we all join one big video call. But for now, before we jump to the second talk, I want to introduce you again a special dude over here. This is Boosted Boris. Hello, Boris. So, first solo.
Guys, can you hear me?
Yes, we can hear you. So Boris is my friend and he have been in this show since episode number 1. He's a developer and he plays drums. So to bring the show one step closer to real TV shows where, you know, there is some little orchestra playing on the background, we thought, well, with a drummer it's even cooler. So we really appreciate having Boris here. Boris, do you feel like playing a little drum solo now as a little break before the second talk?
Yes, of course. Let's do it.
Great, then let's do it. I'm muting myself and we have a couple of minutes to get the beer and get ready for the second talk. So please welcome Boosted Boris! Bravo, Boris! Thanks for a great performance. I hope everyone enjoyed it and got your beer as planned for the second part of the show.
Yeah, I hope to.
Now we want to say big thanks to Boris. Boris also has a blog, and that blog is posted in the video description, where he also has posted about this setup that we have right now, I think. So if you're wondering how it works with this whole chain of electronic drums to Skype to YouTube, you can check it out there. Thanks a lot. We are waiting for more of your solos, maybe pre-recorded in high quality, as well as we are waiting for you delivering a talk, because you are an engineer and you are always welcome at this show. So please, let's say a big thanks to Boosted Boris and jump to our next speaker. Thank you, Boris. And now, Boris, please give us some final support to introduce our next super cool speaker. You ready? 3, 2, 1, and the next speaker is Richard. Richard is old friend of the community. The whole world knows Richard from PyCon Slovakia, the organizer. This is one of the most, let's say it's one of the most popular conferences I can say, even though you wouldn't think right away about coming to PyCon Slovakia, which is in Bratislava. Maybe you should really consider it, because most of the people I know who've been there once come again. There are a couple of things I can advertise right away. The first is that Bratislava is a cool city. You can find everything. It's a nice city, like historical center, architecture. It's also very affordable, both for Eastern Europe and Western Europe, geographically well located. I traveled there on all sorts of transportation. You can go by car, you can go by train, you can fly in. I went on a motorcycle, so this is really a big advantage, I would say. So in fact, it's closer to me, it's faster for me to get to PyCon Bratislava, to PyCon Slovakia than to PyCon Germany. Because Berlin is 600 kilometers, Bratislava is 550. That's how it is. So
yeah, maybe next time you could try a bike.
Maybe. So before we even start, I say thank you, Richard, for organizing this wonderful conference. Please tell us, what are you going to talk about today?
Thank you for your kind words. It's really nice to hear that you appreciate it. I would like to talk about my passion, and it's fiddling with the electronics, and I will talk about home automation, and I will introduce the boards, and since we are on a Python show, I will talk about the boards where you can work with the Python.
Cool. There is one comment that I just have to show before, even though we usually show questions after. That is, are you in the International Space Station? Because that looks like it. Would be fun if now your toys will start flying somewhere on the back.
Over the years, I gathered a fair amount of stuff, so I have to buy the garage, and this is my garage. So whenever I do need to repair something or work something so I go to the garage, because my wife doesn't like when I take the saw inside the house and cutting the wood there, so I need to go to the garage.
Oh God, you're the true maker.
Kinda.
Great.
Self-taught.
Great. I think that we should just start with a talk, because everyone is so excited. It's such a trendy topic now, and you've done it for a while, and you also have real toys over there, as I saw that you're going to show us, right? Live. I'm super excited to listen, and I'm sure everybody else as well. So let's start.
Yeah. Okay, we can start. As you mentioned, the technical problems, we also had technical problems before we started, since I am a Linux user and I was not able to share a screen on my Linux Linux computers, so we have to find an alternative solution, which is my phone, because it has two cameras as well. So I will share screen on my phone, and therefore I would not be able to show any code, even though I have prepared some really small scripts. So maybe next time.
If there will be a need, you will just point the camera on that code. We'll see.
Well, but it's quite difficult to hold the phone in one hand and type on a computer
right.
with a.
Well, I would say it's
smartphone.
not a problem that we encountered. It's the new challenge, the new opportunity. So now let's see how you handle this. All right. Then you started the screen sharing already, right? Then let me just jump
Yes.
to it.
Can you see the slides?
Yes, we do. Python and home automation. All right, then.
All right.
Big applause to Richard, and please start now.
Okay, so as I mentioned in our chat with Anton, I am home automation or fiddling with electronics is just my hobby. I have not studied it. I am self-taught. So maybe if there are some highly educated people here, they might do some additions, so we can have a chat afterwards. However, I would like to talk about some stuff that I encounter during the time I have been fiddling with the sensors and boards. So let's start with this. What is an home automation? I think it's a technological solution that enables you automate some tasks at home. So yeah, I have bought this from Wikipedia. And usually if we go a bit through the history, it started early in the 19th century with the labor-saving machine. Like I think the first home automation was the washing machine or something along those lines. But that's really in the past. In the 70s or in the 80s, there was the first connected electronic devices together, and they were using X10 communication protocol that primarily uses electrical transmission wiring for signaling. However, it's a bit old for me, so I have no experience with it. So we can go furthermore to what can we do with an home automation? We can automate almost everything. Usually nowadays, when we talk about home automation, you can think of about control lighting, HVAC systems like air conditioning, or maybe entertainment system. And all kinds of other stuff. Sometimes it's referred also to do security, like cameras and stuff. Usually, when we connected all those stuff together, we need some kind of central hub that controls everything. Just to give you an example, I found the statistics that home automation market is estimated almost $13 billion this year, and is expected to double by 2022. So, but it's not all sunshine and rainbows. There is a lot of problems, and I will talk a bit about them. There are no standards, or there is very few standards, and it's all fragmented. What I mean with that is that if we look at the, let's say, electronic, there is standard about everything. There is a standard about voltage. There is a standard about frequencies. There is standard about plugs, what kind of plugs we use or what kind of sockets we use. There is standard about battery shapes. So it doesn't happen. Then when you buy a battery from one vendor, it would be different than the other vendor. And in the smart or IoT world, there is almost standard for nothing. Everybody's creating their own standards, and it's all fragmented. It also this is related probably to the legal regulation. So let's say with the classical electricity, there is a strong legal regulation, and if somebody does something in your house, he might be legally responsible for some if there is some kind of damage done. However, this is not the case with the IoT and the smart stuff. So I think the people are confused, and it's not really good for the ecosystem. The other thing is that you have walled gardens. Let's say you buy a Samsung air conditioner, you can connect it to the Samsung cloud, but you are not able to connect it to the Apple HomeKit cloud or some other vendor. So that means that that there is a vendor lock-in, that you are forced to buy stuff just from one vendor, and maybe he doesn't do stuff you want to purchase. So it's a problem, even though and that makes people confused. Even if you decided to buy something else, then you might be forced to use multiple applications, and again, that's really bad user experience, because if you want to, let's say, turn on air conditioning, you need to do one app. If you want to turn on the lights, then you need to choose second app, and that makes people feel uncomfortable, and it doesn't help much, and it makes even situation worse. Even with these vendor lock-ins, it means that they will force to purchase you their stuff. So it's really not a very good user experience. The other things that I think people are afraid of is the failure or the malfunction of the device or the sensor, which could be really inconvenient. For example, if you have some kind of smart lock and you are standing before the door and there is an internet outage, and you cannot get home, that's very unfortunate. But maybe it's also challenging, because if something's broke, then there might be a problem. Find someone who is able to repair it. The good example would be the rebooting Samsung Blu-ray players that happened this year, and nobody was able to repair it unless Samsung create a patch and fix it. And this is really something people don't want to have at their homes. So the other thing is that there are a lot of cool startup companies that create stuff, but the bleeding edge is not the leading edge, and sometimes it happens that the company get out of business and you are on your own, or maybe the company is bought by some bigger company, and then some feature you liked is no longer supported, and then again you are on your own. That's something from the user experience, but also there are problems within the security, and I mean the security and privacy. So as I mentioned, you are sending the data to some cloud somewhere, and you have to trust the vendor, which might be again problem. And it's one thing is that you have some devices that can listen to you, and you have to trust the vendor, and even they say it's just automatically processed and no people are listening. Well, that might be true in Germany or in Slovakia, but I wouldn't be so sure in China or Belarus or some other countries. So that's also a real problem that's in this field. The other problem is the IT security, which means you can own a device that's doing denial of service to some poor website just because the vendor didn't patch the device. Or even worse, there might be compromise when one device is it could mean the access to the whole network. So and we hear the stories about old firmware in routers and expose ports all the time if you are checking some recent security news. So these are the real problems that home automation is facing, and I totally believe that most of this or some of this stuff is really could be really solved with the open source and open standards, and if these could be applied by the big players. However, I'm not going to talk more about this because it could fulfill the whole session, and I'm going to talk about open source and Python and what we can do and how we can create our own stuff, because if you create your own stuff, then you don't have a lot of these problems I have mentioned, because you know what you are doing and you are responsible for your own stuff. So let me introduce you the boards that you can use Python with. The first and the most well-known, I think, is the Raspberry Pi. It's a fairly old board because it started in 2011, I believe, and the original Raspberry Pi had 700 megahertz processor, and now there is the fourth generation, which has 1.5 gigahertz, and it's quad core, I believe. Also, there are a lot of improvements with RAM. It raises from 256 megabytes to Raspberry Pi 4, and as you can see, it has 40 pins which are programmable, and you can connect a lot of sensors to it. I will talk about it a bit later. It costs around 35 euros. If you buy the older version, it's cheaper, or if you buy Raspberry Pi Zero, it's for $5, or if you don't want to pay anything, you can buy a magazine and you can get it for free. So as you can see, we are living in a golden age for makers and what we can make with it. It runs Linux, or it runs normal operating system. Most of the time it's Linux, but you can also run many different other types of the operating system, like, I don't know, FreeBSD, Windows IoT Core, or other stuff. There is all of them are mentioned on the official Raspberry Pi website, so you can go and check it out if you don't know. Let me try to switch the camera. I will. All right. Yes, you can see it. Yeah, here is my complicated setup, but it didn't work. I have prepared some of them. You can see here is the original Raspberry Pi 1. It has only 26 pins, but after that, then they did Raspberry Pi 2, which has 40 pins, and it was improved with the USB ports and so on and so on. This is Raspberry Pi 3. Here I have some 3D printed case, and I think this is Raspberry Pi 3. I don't have 4 here. You can connect a lot of, this one is, you can, Raspberry Pi 3. You can connect a lot of external devices to it. For example, this is the official monitor that's put into the IKEA frame. I just needed to cut a small hole here, and it works fine. So as you can see, it's done by maker. You can make really a lot of different stuff with it. Raspberry Pi is extensible with the heads. If you have been working with Arduino, it was called shields, but heads are in the Raspberry Pi. So you can see there is most of the time no soldering needed. You have some connectors. You just connect them to the pins, and it works. There are many different types of the boards. Here is some educational board where you have already buttons, more pins, and the relays and so on. So you can start prototyping right away. The other type of heads is if you want to learn soldering, you can purchase heads like this that it's not pre-assembled, and you have to pre-assemble it. You have to assemble it by your own, so you can learn soldering a bit. So let me go back to the slides. Yes, so here I have a few other type of heads. Those heads could be really specialized. On the far right, you can see a PyCade head, which is aimed for retro gaming. Down below, there is the Google Voice Kit, which is aimed for building your own voice assistant. On the left side, there is the Explorer head, which is general purpose, where you have where you can prototype simple stuff. All right, so since the Raspberry Pi was the first one, there is a lot of boards, single board computers that are similar. On here you have OrangeP, Odroid, and recently I find about company Pine, and it seems they do really cool stuff. But if you are starting with this stuff, I would keep with the Raspberry Pi just because there is a big community and it's good for education. So if you are starting, you can go to their website and they have a lot of tutorials there. And a Raspberry Pi is also heavily used in the home automation, but it's also in science and industry as well. So let's talk a bit about MicroPython. Before I start talking about MicroPython, I have to explain the difference between a microcontroller and a single board computer. Raspberry Pi is single board computer, which means you have the complete operating system there. But on the single board computer, you don't have the full operating system. You have just one program that is run repeatedly. So they are kind of similar, but the microcontroller has less power, and usually it also requires less power, with energy. So you can run it on the battery. So it's used for a different purpose. So maybe if it's not clear, then I will explain it a bit more when I will talk about the microcontrollers. So MicroPython is implementation of Python 3 programming language, and it includes a subset of a Python standard library. It's optimized to run on microcontrollers, so you can run it on a really minimum environment. I think that the minimum requirements is 256 kilobytes of the flash and 16 kilobytes of RAM. So as you can see, it's aimed for really tiny computers. The other thing is the CircuitPython, which run on microcontrollers, and CircuitPython is fork of a MicroPython, and it's aimed for education, more on education. So it's and it's usually on a boards that are provided by Adafruit, because the CircuitPython is maintained by Adafruit, the company. I think I don't know if everything, but most of the stuff they produce is open source hardware as well. So it's a really cool company. And if you have been on PyCon US 2019, I believe, they were giving boards to every participant as a gift. So you might got a chance to play with their boards. But there is a lot of different boards on their website, but I'm not going to go through them because they are more on education than on creating some stuff. Since I mentioned the education, I have to mention the BBC microbit. This is really tiny tiny board that has only 16 megahertz processor, and it runs. It has the bare minimum for MicroPython, which is 250 bytes, 56 kilobytes of flash, and 16 kilobytes of RAM. It has 25 pins, and it has analog pin, which Raspberry Pi does not. Costs around, I don't know, 20 euros, I believe. So the good thing on the BBC microbit is that you have built-in stuff sensors. So you have accelerometer there, you have compass, you have Bluetooth, you have buttons built in, you have LED matrix. So again, if you want to start, there is no soldering needed. You just plug it to the USB. It boots as a USB stick. You copy your Python program there, and it runs. It's mainly for the educational purposes. Kids in the UK got it. We in our non-profit organization use it for kids education, and it's really, really good because the entry level is really, really low. So if you haven't done anything and you want to start learning, then this board is good for you. So, but let's go to some boards that are more used for doing some real stuff. So ESP 8266. It's a microcontroller that has a built-in Wi-Fi. Usually, or originally, it was designed to connect industrial machines to the internet because it has a serial port, and via the serial port you can connect the machines to the internet. But people see really huge potential in this board, and they started creating a lot of interesting stuff with it. Sorry. Okay, so I have it somewhere on my table. So what you can see, this bit is just the microcontroller, and here is the wireless antenna. So as you can see, it's really small. What I have here is a board called Node MCU. It's like extension board to the microcontroller, which gives you a bit more RAM and a bit more flash. This Node MCU has 128 kilobytes and 4 megabytes of flash because the original microcontroller has only 32 kilobytes per instructions. It costs around 6 euros. So as you can see, it's really cheap. And if you find some smart plugs, relays, or whatever that are connected to the Wi-Fi, there is a really high chance that there is this microcontroller built in, which is good because it means it's really hackable. So I have here bits. I have here Sonoff devices, and as you can see, I will just open one of them. Second, I will open it in front of you, so you can see you can see the antenna here, and here is the ESP8266. It's built into the relay, so okay, you probably don't see it. So again, here is the antenna. Here are the relays, and you can hack it, because originally comes with a Chinese firmware, because it's a Chinese made brand, but the creator of the board left us with these 4 holes, which are pins, and you can connect to those pins, and you can reprogram the device. You can flash it with your own firmware, or you can run MicroPython there, and you can play with it. Some of the boards that are running these ESPs, the manufacturers are hiding this kind of pins. Some of them are more easily accessible, so it really depends. But if you wanna flash your own firmware there, these son of devices are really good, because as you can see, the manufacturer is thinking about people like us who would like to fiddle with it and leave us space there. As you can see, those are different those are done in many shapes. Like this one you can put inside the electrical plug, but be aware it's 220 volts, so it could kill you. So it's not like when you are playing with a Raspberry Pi and you have just 5 volts. The worst thing what can happen is that you can see some steam and the device is broken. But this is something that you should be aware, and you should know what you are doing. So if this is not enough for you and you want more, then there is the ESP. I lost my slides. Sorry. There is the ESP32, and the ESP32 is a bit more powerful. It has 2 cores. However, you can access just 1 core. The difference is that on the ESP8266, the core was shared with the wireless and with the computation. So sometimes you might encounter the rebooting of the wireless or the device, because the core was not able to switch between the tasks. In the ESP32, they've got dual core, but you can access just 1 core, and the second core is for wireless, so you don't encounter such problems. They double the frequency, so it's 160 or 240 megahertz. It has 500 kilobytes of RAM, and the flash is from 4 to 16 megabytes. It depends on the extension board you are using. It has even more pins, but the price is around €9, so it's a bit more pricey. Recently, the Espressive Systems company behind these boards released this year a new board, which is ESP32 SE, I think it's called, and it's similar, but it's kind of step back in a certain ways, because they have just 1 core there, but they are aiming it for the industry, because if you look at the industry, they are using most of the time this board, because it's significantly cheaper. I don't know if this is an official information, but I saw a talk where when someone was saying, when a person from Espressive System was saying that they already sold 100 million of these boards, so which is far more than the Raspberry Pis. So I have to mention Arduino. Even though Arduino it's not really programmable by Python, because it has only 16 megahertz and 2 kilobytes of RAM, but and MicroPython does not fit in there. But what you can do is, if you are willing to have it connected all the time, you can connect it with a Raspberry Pi or computer, and via the serial link you can use Python code to execute it. It's, in my opinion, it's a bit clumsy, and I don't see a reason for doing that, but just to be fair and mention it, it's possible. And the Arduino was the board that probably inspired the smart people to invent board like Raspberry Pis and Node MCUs and so on, because it was used before. So what we can connect to all these boards, we have a lot of different sensors. I'm going to just some of them. This is the peer passive infrared sensor, which can sense movement. It costs about €2. This is the magnetic sensor, magnetic relay. It about the same price, and it detects if something is open or not. This is the temperature sensor. It's DHT22, I believe. It's probably about €4. It can detect humidity as well. This is the gas sensor. It's a bit pricey, cost about €6. And this is the 433 megahertz transmitter, which can transmit radio signals and many other things. Many other devices works on these frequencies, such as garage doors or radio control outlets. So it can be reprogrammed to send a specific signal and interact with such things. This is a gyroscope, which sends the orientation of the device between 3 axes. This is analog humidity sensor, which is placed in the ground and measures the humidity by current flow between the stands. So if you have some plants and you want to see if the ground is dry, you can use this sensor. However, this is analog sensor, so with a Raspberry Pi you would have to have either a head or do some different thing to read analog signals. I probably didn't mention what's the difference between analog signal and the digital signal. The digital signal is either up or down. It's 1 or 0. So either is there voltage or there is no voltage. And in the analog pin, there is certain amount of voltage. So you can measure like 0.2, 0.3, 0.4. So it's not just 1 on 1 or 2. So that's the difference between the analog and digital pins. This is a sensor for measuring distance. It's ultrasonic, so it transmits sound from the one speaker and the other one is receiving, and it measures the time, and from the time it calculates the distance. So you can measure the distance. This is the servo motor, which can be individually controlled, and this is the potentiometer, which is basically rotable resistor, and it's all, again, the analog signal. Okay. Maybe I can show you. Oh, I haven't been talking about the relays. So there's more sensors on my table. There are more sensors. You can see this one is measuring the temperature, and it's waterproof. So if you have aquarium or something like that, you can use this one. This is sensor for detecting sounds. So if there is some noise, it will trigger. A relay. Maybe I could talk a bit about relay. Relay is really interesting because you can, with a small voltage, you can control real stuff like if you have a pin on the Raspberry Pi that has either 5 or 3.3 volts, and you want to turn on the light bulb, which is on 220 volts. So it looks like an impossible task for the Raspberry Pi, but with the relay you can do it, because there is just string inside, and there is the magnet, and when you put 3 volts inside the magnet, it just manually turn the on and off knob there. So maybe if you can see, like the schema here. So there is the NO and NC, and if you put some energy there, it will just switch. So it's like classical plug. So but once we have sensors, we measure something, we need to send it somewhere. You can send it, you can do all different kind of stuff. So if we are talking about the Raspberry Pi, you have the full operating system there. So you can either run your own database, or you can send it somewhere to the external database, or you can send it to the API. But usually that's not the case when you have microcontrollers and you have to send it somewhere else. It could be either third-party cloud, or you can host it by your own. I would say the de facto standard here is the MQTT, which is a mechanism that can send messages. It's a PubSub protocol. There is a publisher, there is a subscriber, and they both connect to the broker, as you can see on the slide. And the publisher sends some topic and the data, and the subscriber subscribes to the topics and get the topic from the data. So as you can see, it works both way. So if you have a Raspberry Pi and you are running broker somewhere, and some other sensor does something, you can send some message to the Raspberry Pi, and it will do stuff what you program in it. So the thing is that when you have all this, it's not really very user-friendly, and for that purpose, people created platforms that can integrate all of this. And my favorite is Home Assistant. It's written in Python. I forgot to mention. I forgot to mention that in the MQTT, it's you have really good support with the Python. So there is a lot of even brokers. There is a lot of libraries that do clients, and you can fairly easily program that with a Python. So, and Home Assistant is something that puts everything together, and you can have all of it within nice dashboards, and it's all integrated together. So let me show. Okay, so here is my dashboard, and as you can see back there is the light, and I will just click on the button and the light went off. Again, I will click on the button and the light went on. So this gives you a possibility to use it as a central hub for your home automation, but one thing is that you could build yourself some kind of appliances, but most of the time, or sometimes, we don't have the energy or the knowledge to build everything. For example, in the past I mentioned the AC units, like climatization, so that's probably out of scope. So you could look at the home automation home assistant website. They have like a ton of integrations, and you can integrate with a lot of stuff there. You can integrate with the third-party clouds. You can integrate with MQTT and do your own stuff. Home Assistant has also built-in automations, which means that if some sensor does something, you can easily configure Home Assistant with the YAML files to, let's say, send you an email, so you don't have to configure multiple Raspberry Pis, or if you have some microcontroller that doesn't know how to send emails, or it's not the trivial task to program there how to send emails. Home Assistant can do that for you. I mentioned the ESP boards. There is the thing which is called ESP Home. It's custom firmware for the boards, and it easily integrates with the Home Assistants. Again, if you want to flash it, you just pip install ESP Home, connect it with the cables, and you can flash it. However, flashing might be not so trivial, but with a bit of playing, you can do it by yourself, and then you can connect these ESP boards really easily, or you can program it in MicroPython and MQTT. It's up to you, because if you are creating the things, then it's up to you how to approach the challenge. And I think this is like the basic overview what you can do, and how you can use Python. As you can see, it's either in the boards or either in the microcontrollers. You have the libraries for communication, you have the platform that you can use, so you don't need to step outside of the Python ecosystem to start creating your own stuff. So I hope for the beginners they got some new information, maybe even the more experienced people find something new, but this is something I have learned along the years, and I think it's missing, because either there are the tutorials for the children, or there is the expert stuff for people who knows what they are doing. And it's really cool to create your own stuff, to be creator, not just the consumer. And I encourage you to start with a simple project like measuring temperature, and then just show it somewhere, or maybe if you have some pet aquarium or terrarium, just to turn on off the lights or so on. And I think you will enjoy it.
Thank you very much. It was a very good introduction. It's a sort of a advanced level, I would say, already. I have a party here. It's my lovely friend Alejandra playing with the lights for fun. She watched it as well. It was good. So now we have Q&A, and let's just jump right to it. So, apart from the International Space Station, okay, what have you actually built? Can you show some examples?
Right. Sure. So, how would I do it? Oh, with the, let's say, you can see the dashboard, and if I go Okay, you can see the stuff on the dashboard, and I'm just going to move around and open the door, and you will see how the stuff changes. Hopefully that was pointing on the display, and you could show it. So that's a Raspberry Pi with a simple while loop, and it's detecting this magnetic sensor. Once it's open, it sends to the MQTT message, and the Home Assistant picks the message and shows it on the display and sends me an email. The other thing what is there is a peer sensor, which I don't have on my table, and it detects the movement. That's one thing. The other thing that I have in my second garage is I connected the old Nokia phone to the Raspberry Pi because via the USB, and because I don't have internet there, it just dial links the number when the door is open. The other thing is this light, what I have already shown. That's the ESP. That's the ESP with a relay. I have also a ventilation system that turns on the ventilation, but that's not automized anyhow yet. It just it works just on pressing the button.
We believe you, Richard. We believe. Don't have to show everything, but it was just interesting, I guess, to see the real application that you can build. Cool. Thanks a lot for showing this, also with examples. I saw how you struggled with the camera. I tried to help, so was at the end quite smooth, I would say. Yeah, but you showed a really good creativity switching to your tablet, and that's cool. Okay, now I'm plugging myself back here. I see a lot of comments of people leaving because it's late, but they loved your talk. Very interesting talk. I have to leave, thanks. Or I'll need to drop, but thank you. This is actually not true. She's sitting right here. But maybe it was just a way to say compliments to you. Maybe you should invite everyone to PyCon Slovakia. By the way, maybe it's an off topic. You hope for PyCon Slovakia next year?
I hope so, but it's tough times because we had to postpone, and then we had to postpone again. So currently, we would like to have PyCon Slovakia in May or June next year, but we will see. It really depends on the situation.
Yeah, I hope it works. I hope so much. I'm supposed to be a speaker there. I received these emails.
Yeah.
But I saw you're optimist because I canceled PyCon Web right away. I thought that if anything happens this year, that would be PyCon Slovakia because it was not canceled, it was moved. So maybe now you move it again, you still have a chance to do it.
Yes. We already bought the T-shirts and have a lot of stuff. So and it's stuff that's not it's not going to get bad. So it could wait in my International Space Station.
You don't have the year on the T-shirt?
No. It hasn't been printed. They were just shipped, and well, we were lucky in the unlucky times.
Got it. Okay, so if we don't have more questions about the main topic, about the home automation, then I'll just ask you some more off-topic questions, and then we're done because I think people are already sleepy. Richard, how about this non-profit organization you're running? Does it have any other activity except of the conference?
Yes, it does. It runs the meetup here in Bratislava. That's one thing. The other thing is that we are working a lot with the BBC Microbits, and we are aiming for kids in the elementary schools and in the basic schools to teach them how to program, because I haven't mentioned it. You can also programming with Scratch, which is like drag and drop programming. So even the children that they will learn the concepts of like while loop and I don't know concepts of programming.
Cool. Yeah, I remember these workshops on the conference. That has something to do with it, or?
Sometimes yes, because we had on the conference, part of the conference is aimed for the teachers. So we show our teachers are teaching themselves how to teach better and showing themselves what they do, how they can improve, and latest and greatest trends. So yeah,
Cool.
it's a good cooperation.
Cool. Okay, we have 2 questions about the main topic, I guess, so we will just have them, and then it's over, and we can get to the beer part. First one, what about K and X? I don't even know what that is. Do you know?
K and X.
Yes. No.
Sorry.
Okay, if there will be a follow-up comment with the full word, I will display it. But now we go to the second question from Anna. What was your very first project?
My very first project, I think Hello World in the hardware is to start blinking the LED. So you just take one LED, put it into breadboard, do some simple cables, and with the Python you just send a signal to the GPO and it blinks.
Your first electronics project was in Python. I mean this circuits thing.
Yes, I started when the Raspberry Pi 1 came out.
Not Arduino.
No. Arduino is C. I don't know how to program C. I'm not a C programmer.
But it is a very useful device to collect the dust on my shelf. I have it, I can't program it. Okay, now we have a follow-up. K and X is the home automation bus standard. This is why I was asking. Well, good to know. Maybe we should check it out on the weekend then. It's a bus standard.
Yeah, well, I haven't got the opportunity to program it, and neither I have the project to work at it. I just use what I find out on my way. As I mentioned, I am self-taught, so maybe that's the reason why. And yeah, I will check it out, and if it's cool and it would help me out to improve the projects, I will definitely try. So thank you for the comment.
Very good. Also, thanks from me. Thank you, Richard. Yeah, I'm happy that we managed it. I think we also tried to find the day for about a month or so, and now it's today, so I'm super happy. I also think that your talk will help the other Pythonistas to get into world of home automation and microcontrollers, and I hope to hear the extended version on some next conference. So, yeah. Good. So how it works now? Now we say a big thank you to Richard. Yes, thank you, Richard. Unfortunately, Boris is not here anymore, so no drums, but I'll try like this. Good. Thank you very much.
You're welcome.
Okay. Now, as a wrap-up, yeah, I say thanks to everybody. I invite Alejandra, who's been here the whole time. Alejandra, come. She helped a lot. Yeah, that's Alejandra. And I want to say thanks to the audience. So I didn't have a chance to comment much on that, but I saw many familiar faces. I was super happy to see that people are coming back, that they didn't forget us. That's a lot of support for me personally, but even more for our speakers. That's what motivates them, maybe for the next part. Hopefully Alejandra also stays. Maybe she also makes a talk. Yeah. Today she started with serious Python. With serious Python. The first question was, why the hell is 120 lines or 80 lines? What is this debate about?
Why is this a problem? Yeah.
What's the problem in the Python community about that? It is a problem. There is a lot of debate still. There is no common value. It will be funny to make. Maybe we do a holy war in the next episode.
Yeah, why not?
A holy war about this. Good. So now how it works. We still stay online for some minutes. We want to chat with everybody, so if you are not too sleepy yet, join our Skype meeting. The link is posted in the description, so actually on the very top of the description. So if you just reload this page right now, on the top you will see a Skype link. You click on it and you join our call here, and you show yourself, you say hi, or criticize us off record. That's also useful. We can also ask personally the questions to our speakers if they're still online. I don't know. It's a bit late, so I'm not sure. But yeah, I will be happy to even just say hello personally to everybody of you or any one of you. So yeah, join now. And at this point we can end the broadcast already and just stay in Skype for some minutes. So thanks a lot to our great speakers. Thanks a lot to our great audience. I hope to see you in 2 weeks. I aim for 2 weeks, 3 weeks max, because we already have speakers. So big thanks. I see you. Bye.